All right, I've got to get you through. I got to get you through this. All right, so surfboards. Why do we wax a surfboard? Why do we put? Okay, so this whole thing has been about increasing or decreasing friction. You can read through these slides if you want, and stuff. And we talked a little bit about the drag, hovercraft. Here's an LCAC, noisiest damn thing you'll ever. I know some of you probably been on them. I've never been. I've been on the L. I think they can come off an LPD and some other amphibious ships too. I can't remember because I was always on an LPH, but there's the big, huge new amphibious ship, and I can't remember what it is. But anyway, hovercraft. You blow air underneath. You get air underneath that reduces friction. Play air hockey. Those are all kinds of cool things for reducing friction. Now, but sometimes you want to increase friction. All right. Sometimes you want to increase, and we've got this little hovercraft in our physics lab. By the way, these three students, these three kids here. These are my former chair. He's moved on to South Dakota State. These are my former chair's kids years ago. All three of them are, well, in fact, this one just graduated from medical school, and these other two are in medical school right now. So anyway, bearings help reduce friction in things. Wheels, of course, reduce friction. Surfboards. We want to increase friction. Why do they wax the top of their surfboards? Yes, to increase. Now, there's a cool little. I've got a video on there about watching what causes waves in surfing, and it's kind of a little geeky, sciencey thing. You don't have to watch that one. In fact, the sports videos that I haven't read are the ones that have specific questions about what we're talking about here. And I think that's it on friction and static friction. I already talked about that. And we'll get into that when we go into the sled dogs and stuff like that. But I think everything else. Oh, we got to talk about curling. My bad. Oh yeah, and I wanted to talk about this. All right. Sorry. I do my regular lectures this way too. So don't panic. Ice skating. Water freezes at zero. However, have you ever noticed that even on freezing days, if you fall on the ice, and in fact, when you watch the curling video of the guy, he falls on the ice and he gets up and he's soaking wet. Okay, he says, "I wet my pants." All right, and that's because the surface water acts as a lubricant. However, there's a thin layer of water, and that's why we can't skate on a rink of glass, because there's not that thin layer of water that causes lubrication, so we can actually skate. And so, in other words, if you get down to minus 25 Celsius, that's freaking cold. All right, that's about 38 below zero. All right, so when you're down, well, actually at 40 below zero, at 40 and 40, they're equal. It's probably around 31 below zero or so. I mean, that's cold. You can't skate then. All right, doesn't work. But this thin water, this very in nano, I mean thickness in nanometers. Look at this. Thickness, it's like 90 or 20 nanometers, or an angstrom thick. It's really thin. Curling, great sport. Please watch the Curling Rocks thing. It's only 25 seconds. It's hysterical. All right, on Not in My House, Not Tonight, on curling, and we'll get into the physics of curling a little bit. Okay, and I have you watch and sandboarding is another way to reduce friction. But I have you watch a video on the science on Smarter Every Day, on the science of some of the science of curling, and we solve one of our simple little problems using the frictional forces. All right, on this. Okay, so let's stop here, and now we're going to get to air pressure, which is really cool. So in other words, this is a long lesson. All right, this is a pretty long lesson. I agree, but now we're going to get to air pressure, which is really cool. All right.